This presentation relates to an incident that occurred on a Subsea 7 vessel in October 2012 in the UK sector of the North Sea. The vessel was working on the replacement of a dynamic umbilical as part of a control system upgrade at an FPSO. The weather conditions were within acceptable limits for the operation. There were no injuries to personnel due to the incident. However, the investigation concluded that there had been a potential for a fatality. The first part of the operation was in progress, to set the umbilical into the tensioner. The umbilical reel was being paid out, while the umbilical was fed around the guiding quadrant, and the end fitting, supported on a two-leg sling, is being lifted over the chute with the intention to capture the umbilical within the tensioner. The deck layout shows the plan view, and the red dots indicate the location of personnel during the operation. A trial lift was performed prior to the start of the operation, and no issues were identified. We see from the start of the video that as the umbilical head is lifted, the angle to the horizontal increases. And as the lift continues, the angle to the horizontal continues to increase. The two-leg sling is no longer taking load on each leg. The rear leg is progressively taking more and more load as the increased length of the product off the deck, the back tension from the reel and the friction from the quadrant have an influence on the crane load and the angle of the sling to the vertical. The failure of the rear leg of the dyneema sling arrangement caused the umbilical to fall onto the lay system walkway. Fortunately, the forward sling withstood the subsequent shock load and was able to support the whole assembly and prevent further collapse. Immediately prior to the failure, the rear sling is in contact with a sharp edge, the wedge ring locking assembly on the umbilical head. The load in the sling is peaking at 10.5 tons as registered by the crane log, which is significantly higher than the total load expected, 6 tons as detailed in the lift plan. The crane operator was aware at the time but did not communicate this to the deck foreman. So, how did we arrive at this point? What were the mistakes that were made? And what can we learn? The original rigging drawing shows steel slings each 15 meters long, connected to the head by choked dyneema sling, 35-ton minimum breaking load. The drawing does not show any anodes on this part of the head assembly. The drawing had been approved for construction. However, there were other drawings from the client supplier showing anodes at this location. A trial lift was performed with the steel slings, and it was immediately apparent that there was a conflict with the anodes. The choke sling was moved to a position between the anodes and the wedge ring. In addition, there was concern about the head height under the crane, and as a result, the 15-meter wire rope was replaced with shorter dyneema slings. The personnel on board did not consider it necessary to follow the management of change process. However, the deck crew were concerned with the sharp edge which might contact the sling, and made a token attempt to protect the sling with neoprene. The lift plan that was signed and approved shows the original steel sling arrangement, which was now no longer being used, and shows a PDF of a storyboard sketch from the procedure. Neither represent the reality of the lift situation. The storyboard sketch takes no account of how the load would react with the length of product lifted from the deck. If it had, it would be clear that the load would not distribute evenly between the two slings, as shown. There were no calculations produced for the lift. According to the record and the investigation report, no one could see that the rear sling was in contact with the wedge ring. And again, according to the record, the slack forward sling was not identified by the crane operator or the deck foreman. The investigation report identified 4 causal factors. These are mistakes or failures that, if corrected, could have prevented the incident from occurring, or would have significantly mitigated its consequences. 1. The AFC rigging drawing was incorrect. A clear area was shown where anodes were located. There were inconsistencies, but there was sufficient accurate information in the supplier's drawings that showed the anodes. 2. There was no specific lifting technical review or analysis of the lift during the engineering phase. Had the lift been classified as an engineered lift and been subject to additional technical review and analysis, the additional weight of the umbilical, change of centre of gravity and head inclination would likely have been recognised and an alternative arrangement proposed. 3. The rigging design was incorrect. All factors had not been applied. The sling was undersized. There were no formal written calculations, and the requirement to do this was not recognised by the project engineer. 4. The attachment point clashed with the anode position. The sling was moved closer to the wedge ring, but no management of change was performed. Had an MOC been raised, the sling contact with the wedge ring may have been foreseen. Conclusions detailed in the investigation report. Training and competency of project engineers and supervisors to design, check and approve rigging arrangements needs review. Moving the sling position plus a change in the sling type and length did not trigger an MOC. Training of offshore crews and project personnel in the understanding of the MOC process needs review. The umbilical head lifting and installation method was not fully addressed during the early design phase. An installation review should be instigated with the client as early in the design as possible. Interface meetings with the client's hardware designer and umbilical supplier should formally consider the design of the equipment for the installation phase. The global engineering processes within the BMS will be revised to incorporate the recommendations from this incident report.